Hi, this is Eric Turner with EA Electro-Automatic. This video is going to cover the function generator that is part of our programmable DC supplies and our programmable DC loads. Now it's common that our customers want the ability to be able to fluctuate voltage over a period of time and basically be able to create custom waveforms using the programmable DC load or the programmable DC supply. So what we're going to show you today is a couple of the functions that are available in both of these products that allow the customers to be able to either program, for instance, ripple on top of a current or be able to create custom current profiles. So today we're just going to show you a couple of those, and what we have here is our PSI 9080 170, which is our auto-ranging programmable DC power supply, and also our ELR 9080 170, which is our regenerative DC load. So let's go ahead and take a look at some of the functions that are available. So simply come into the menu, select your function generator. Here you can see we have just kind of a baseline of, well, do you want to generate a sine wave, triangle? Do you want to do a rectangular wave, for instance, to be able to create a pulse width modulated load profile waveform, trapezoidal waveforms. We even have DIN standards for automotive tests. And of course, we also have arbitrary. So the arbitrary, you can either build through the front panel, or you can go through CSV software and simply generate an Excel file and come back into it and be able to download it directly into the source. But let's go ahead and take a look at a real simple one. So what I've done is just selected a sine wave. I've selected that I want to create current. So what I've done here is say, look, I want my ripple to be about 5 amps. I want a 30 amps of offset, so it's going to drive a fundamental of 30 amps, but then be able to put a 5 amp ripple. And I programmed the frequency for this particular case to 1200 hertz. We'll go ahead and go to the next one where you can set in limits if you need to, if you're worried about protecting your device. But we'll go ahead and load it into the load. So it is now ready to operate. So what you'll see is I'll go ahead and start that profile. And what you'll notice on the oscilloscope is now we have our offset of current and we have the ripple voltage riding across. We'll just do a quick measurement here and be able to show you. So you can see now we have our ripple and we're sitting right at 1.2 kilohertz. So that's just a very simple way of being able to create, ripple to be able to test your product against susceptibility to maybe less than perfect current conditions. So next we'll kind of scroll down. We'll go ahead and go back. Let's take a look at another feature, which is, for instance, a rectangle. So here what I've done is go ahead and programmed in. I want 20 amps on. I want 0 amps off. So you have T1 and T2 programmed. I put both times at 100 milliseconds. So we're going to go ahead and load that in. And again, you have your safety features if you need those as well. So once this is loaded, let's go ahead and get rid of these and we'll go ahead and start it. So what you'll see here is now the current is, let me get this a little bit finer here. So what you'll see now is we've created this pulse width modulation where there's 120 amps on for 100 milliseconds, 20 amps off. So that would be, again, creating pulse width modulated current waveforms. So now we'll go ahead and take a look at trapezoid. So what I've done is programmed a current here of basically saying I want to go from 0 amps to 30 amps over the period of 50 milliseconds, stay there for 10 milliseconds, ramp down T3 at 20 milliseconds, stay there for 1 millisecond, and then repeat that sequence. So we'll go ahead and load it in. Of course, you have your safety features as well. We'll go ahead and load it. Go ahead and start it. So what you'll see here is, let's go ahead and pause this. We'll take a couple measurements real quick. So maybe take a look at the fall times, ramp times, either one. So what we programmed in here earlier was a 20 millisecond ramp time. Oops. So you'll see right at 20 milliseconds. Now, this is a more in-depth way of being able to create a dynamic load profile using the various features. Now, again, one of the things you can do is, yes, you can get in here and program all this from the front panel. You can see it's a very nice touch screen. But if you want to be able to create a very elaborate profile, some of the best things to do is come in and actually create an arbitrary current wave shape. Now what this allows you to do is program a sequence of between 1 and 99 sequences. And what you'll see here is you notice you can actually import or export through a USB. So what you can do is take your files and actually create them in Excel, save them as a CSV, and download them directly into the DC load, and then it will recreate that load profile that you've done externally. So there's lots of different features here. You know, being able to ramp, for instance, over a period of time is another feature. So the function generator really makes your life simple, because previously on standard DC power supplies, you'd have to couple in a function generator to be able to generate any kind of ripple or be able to drive it through an analog signal. Well, both the PSIs and the ELRs combine those two instruments into a single instrument and really speed up that process and increases your test repeatability as far as being able to get really accurate results that are exactly the same every single time. So that same arbitrary waveform and function generator that we saw out of the programmable load, of course, is also available through the same menu structure on the programmable DC power supplies. So between these two combinations, you can both create dynamic load conditions and be able to create dynamic voltage conditions to really fully test your product.